Hi everyone, thanks for joining us today. The topic for today's webinar is Simplifying MLOps with Model Registry. Before diving into the presentation, here is a quick intro about me. I am heading product at Verta, and at Verta what we have built is a platform that essentially helps solve the last mile challenges for machine learning. What we do is we enable data scientists do better experiment tracking, versioning of models, and eventually deploying and monitoring ML models at scale. And today I'm really excited to talk to you all about Model Registry and how it can simplify taking ML to production. But more importantly, I'm really curious to talk more about how this process can empower data scientists and give them more control in the process. And throughout the presentation, we'll answer some of these questions. First of all, what is a Model Registry and how is it relevant in context to MLOps? Why do we need a registry? Primarily from the lens of how it can help a data scientist. Next, we'll talk about what functionalities and features you should look out for in a registry, whether you are buying or building one. We'll also see a demo of Verta Model Registry. And finally, we'll recap, followed by Q&A. Now, this is one interesting statistics. In next 3 to 4 years, 75% of the companies are planning to graduate from pilot to operations for their ML projects. That's really exciting, right? And of course, then businesses are seeing a lot of value and they're really gearing towards moving forward. However, here's the reality check. We still have a lot of challenges when it comes to turning POCs to products that are truly production ready. And that's the worrisome part. And I don't want to preach to the choir here. I know that you all go through such pain points every day in your ML initiatives. In fact, we have come a long way with the really advanced ML algorithms. We have very mature training or workflows, but unfortunately, when it comes to productionizing them, the state of the art looks something like this. Again, there are too many ad hoc processes. We use spreadsheets, we use tools that do not simply work, and also we end up using tools that are completely misfit for data scientists or our ML workflows. That's the reason why now we are seeing a new breed of tools that are focused on MLOps that helps deliver ML much faster. And as we see the entire MLOps lifecycle, I kind of put them into these two buckets. There is ML and then there is Ops. When it comes to ML, we are talking about how you plan your projects, create, test, and package them. And for Ops, it's all about how do we release, operate them, scale them, and monitor. And between the ML and Ops processes, Model Registry really fits in the middle. And I would say it's the linchpin to make MLOps work. All right, so Model Registry is key to MLOps. But what is Model Registry? Now, the Model Registry is a system that allows data scientists to publish their production-ready models. So once you're ready with your experimentation phase and you're ready to share, you are using Model Registry to collaborate with other teams and stakeholders. And if you step back and think about how we work as data scientists, we are starting with experimentation until we decide on a model to deploy. And Registry really fits between the experimentation and the deployment phase, where you're staging your model that's ready for the release. Now let's draw some inspiration from the software universe, right? How do software releases work? There we have solutions like Docker Hub, Artifactory, PyPy, and many more. Taking Docker Hub as an example, with the container registry that Docker Hub provides, developers can store and distribute images. They can tag different versions. So the releases are version control, and everything is happening from a single hub. So they go and build and publish one image. That's happening once, and anybody can download that image and it runs seamlessly. And it also helps them collaborate and work with the other stakeholders, be it QA, be it Ops, and other peers. And in the end, Model Registry, how we see it, it really takes a very similar approach for machine learning. Now let's talk about why Model Registry is so important. Now, you have spent so much cycle in building an algorithm, let's say, that works amazingly well. And you believe it has huge potential to essentially impact your business outcome. Maybe it's going to help increase the conversion rate in your website or improve the product recommendation engine. And at the end, you want to quickly release it and finally keep iterating on it. What frustrates you the most? Rolling out ML to production is painfully slow. We have spoken to teams who have taken somewhere between 1 quarter, 1 year to sometimes 2 years to release one model. And that kind of timeline could potentially in the past would have worked with hardware, but that's not going to cut it for machine learning. And again, I want to bring another interesting point here. The job attrition rate for data scientists is very high in the industry. And there are countless articles written on it. And again, I wonder if these broken processes are another contributing factor to it. But overall, like having a slow production rollout process and things not working out hurts both the data scientists as well as the businesses. Now, what slows down ML rollouts? You are running a bunch of experiments. You're trying out different algorithms, tuning few hyperparameters, and typically you're not comfortable sharing the tens and thousands of iterations that you're working on with the entire team, but rather you'd go for sharing the best fit model. This ad hoc process sometimes makes it harder to identify which models are production ready. And even if you know what model is ready and you want to hand it over, the handoff process is sometimes broken when you are handing it off to your engineering or your ML infra team. The handoff process is generally not elegant, and this is where things break down. And what we lack is better transparency and a way to collaborate with other team members. Ultimately, the goals of both the teams are the same, right? We want to move forward and release the model, but the approaches that we take and the process is not that streamlined, which kind of creates more barriers. But instead, what if we have one central repo where you are staging all your release ready models? So your deployment counterparts can just go and take the model, download it from that repo, and you keep iterating and adding the future versions to the same repo. That kind of would streamline the entire release and handoff process, and that's where model registry can add a lot of value. Another aspect of ML is how finicky ML models are, which we do not see with software. Again, with the slightest change, even a library version or one environment variable, a model will produce very different results. And in reality, what we have seen, development, QA, production environments could be very different. And you don't want to create unexpected last-minute issues when you're handing off your model to another stakeholder who will end up working in a very different environment. And again, we have heard horror stories from teams who have spent weeks figuring out why a particular model is giving a different prediction on development versus production. And all of those could boil down to a small change in the version of one of the libraries, or it could be that the training was done on GPU versus CPU, and nobody was bothered to document that. Now, model registry kind of comes very handy in this process to help eliminate these kind of inconsistencies and undesirable delay. Because with a model registry, what you can do is you can ensure that anytime you're making a model ready for release and logging it to registry, you're also logging the key model ingredients that the stakeholders can access. When I talk about ingredients, the key things that I'm talking about is data, any configurations, which could be your hyperparameters, the environment variables, which are the kind of the underlying libraries used, including the version number of each library, your model code, as well as the documentation. So your stakeholders do not end up making any assumptions. So you have everything in one place. Next, we'll talk about lack of governance and security. This issue is present in many industries, but I'm just picking on healthcare for now. We have heard stories about how United Health used an algorithm that was biased towards certain race. So what the algorithm was essentially doing was prioritizing the patient care, the amount of investment that hospitals need to make based on the level of illness that a patient has. And when it was audited, it was found that Black patients are assigned the same level of risk, even if they are sicker than the white patients. And interestingly enough, the algorithm was predicting healthcare costs rather than the actual illness. So this was completely biased. And again, this is just one example of the extreme lack of governance that we have when we are launching ML products. And it ultimately bites us back because that slows down adoption, and then we go back to the whiteboard to think, okay, what went wrong? What should we do it right? And again, another interesting take on this is how ML is used for pandemic responsiveness. And ML is showing a lot of potential, right, to be used in things like contact tracing, symptom tracking. But again, there are a lot of questions around how can we ensure that ML is used correctly without really impacting any human rights. And these questions are being asked by legal team and other stakeholders. Now the onus comes back to data science teams. And the impact is the amount of risks we are putting on businesses, brands, and human rights until it's done right. The ML governance is that's imposed today is very ad hoc. I'll give you some simple examples. For example, you have to worry about, for example, you're using so many libraries, right? We'll end up using many libraries. How do you easily track and maintain a list of all the underlying ML libraries? Maybe it's NumPy, SciPy, you'll have so many libraries. Is there a place to track everything and also manage the specific version that you are using? Next, you have to think about vulnerabilities. Is there a way for you to track these libraries, their versions, and also scan for vulnerabilities? And this is mostly missing in the release process. Again, most of the ML applications, whether you want or not, will end up dealing with PII or PHIs, personal and health information. And you need to ensure that you are anonymizing the data, or the data is handled appropriately based on the rules set by your company. Now, third is how do you review and ensure that the open source product libraries that you're using, any libraries, you are not crossing any license constraints or barriers. These are just few examples, but this could be the list is much bigger than this. But all these questions for all these scenarios, there is no formal process. Everything is very ad hoc. That's why things fall through the crack and create such kind of nightmare that we saw in the other slide. Now with a model registry, you can manage the life cycle of a model from development, staging to production to end of life. You can also implement a formal model governance and approval process. You may have your legal team, your business team, your technical stakeholders, maybe your security, and they need to review and approve prior to deployment. Right now, unless you have a proper approval process, it's very difficult to put all these workflows in place. But at the end of the day, it's your company-wide model inventory that lists all your ML models, all their associated data, their usage, how dependent they are on each other, their assigned risk levels, so everyone is on the same page. The visibility and collaboration you're seeing with ML projects are somewhat broken. And this is a quote from head of data science in a US bank. We have half a dozen teams using half a dozen different ways of building models, as many places to run them. We have no central place to get visibility at an org level. Bottom line, data scientists are siloed. You don't want to reinvent the wheel, right? You'd rather much prefer to take the work of another data scientist and just build on it, work on something novel versus working on the same thing or same problem that has already been solved, right? How often do you have that luxury? Because the organizations are so siloed, even if there is a solution, there is no way for you to find that. What you need is one place where you can find all your models. No matter where it is, staging, production, or end of life. Anyone can discover, anyone can iterate and collaborate on it. So you are creating value versus creating silos. And model registry in essence provides that kind of capability. You can think of it as like a data warehouse for all your models and the artifacts. All right, so model registry helps with A, faster rollout of production models, B, improved governance and security that gives you peace of mind, and C, it creates visibility and collaboration. Now let's switch to features and capabilities. Let's say if you are in lookout for a model registry, if you're building or buying one, what features and functionalities should you consider? I'm looking at from a lens of, again, how we will proceed through different ML stages. You are starting with an experimentation. So it's really important to make sure that the model registry integrates and works well with your experiment management system. So if you're running multiple experiments and you're pushing one experiment to your staging and release process, all the associated information should flow into your release pipeline. I'll quickly go through a demo of Verta platform to showcase how that works. So we'll switch back and forth between this presentation and the demo to talk about features and functions. I'm starting with a notebook, and this kind of gives you an idea of how the experiment management works within Verta. And we're using a Python library, which is simply a library that works with any of your model training environment. And you'll start with the model development phase. So you are instantiating a client, and you can have your data in AWS or somewhere else, but you're essentially preparing your data and then configuring different hyperparameters and training your model. And this is how you'll run multiple experiments with different hyperparameters. Information that you will end up logging could be your different attributes, your hyperparams, the accuracy and different metrics, the deployment artifacts, as well as your training data, and for example, your code or Git information. So there is a bunch of ways that you can track different components and artifacts and information about your model as part of your experiment run. I am not running this experiment in the interest of time, but I've already run this. So if we go back, this is a view of our web app where you can track all your experiments and review them. So the thing that you're seeing here is our development phase, where you can go and look at a specific project. And in this project, we have logged multiple experiment runs. So in this case, you have logged maybe 20 or 30 different experiment runs. And in real world, in ideal scenario, you'll be running hundreds or thousands of them. And you are looking at different metrics and hyperparams to compare different experiment runs. So you may go to our charts and see how these runs are performing and compare to different accuracy, or you can compare and contrast with different hyperparam groups. But at the end of the day, you decide that this is the best run, this is my best configuration, and I want to go ahead and release this to production. And in this case, I'm just sorting by accuracy. So I want to go ahead and register the run that has given me the highest accuracy. And if you're a UI person, you can just go ahead and register through our UI. But instead, what I'll do is I'll show you how to do it in the notebook. So in the notebook, once I'm logging all the experiment runs, I will go ahead and retrieve the best run. And in this case, I'm looking at the metrics value accuracy and ordering it in terms of descending order so that I can get the run with the highest accuracy. So let's run this and see. That's giving me the validation accuracy of 0.7945, which is the best model from all the ERs, which is same as what we are seeing here in the top of the list. And I will then take the best run model and train it with a full data set. And finally, I'll calculate the final accuracy, and that comes out as 0.7904, which is fine with me. And this is when I move from development, as you can see in our web app, from the development phase to registry, which is your staging phase, when I know that this is the model that I want to release and I want to get it in the hands of other stakeholders. And what I'll end up doing is I will go ahead and register this particular model version. You can either create a new model, and in this case, we already have the model census demo as a registered model, and we already have a previous version that is already logged. So I'm going ahead and creating a next iteration. So let's go ahead and register this particular model version. So as you can see, I got that there is an existing registered model census demo, and it has created a new model version, which is V2. Let's go ahead and again, this is our model registry, and you have the census demo model registered here, and you can see that there was already a V1 registered model which is in archive state, and now I just moved a new registry to development, which is version V2. And if you go to this specific model, you will see that the stage is development, and it is associated with this particular project from my development cycle and this particular experiment run. And in addition to all this information, you'll also have information about the attributes, the package, as well as different artifacts that is being used in the model. For example, you can go to the level of what libraries used, what versions have been used. So everything is tracked here as part of the registry. So your stakeholders can easily access all the information at one place. And again, speaking of the feature that we just discussed about having seamless integration with your experiment management system, if you go here and click on the experiment run, you are actually going back to the experiment run that you ran during your development phase. So this is the run ID, the timestamp, all the hyperparams, use metrics, attributes, the artifacts, code versions, so what was the Git code that was used, data sets, what training data sets and validation data sets that you've used, as well as it gives you back a link to the model registry where you have logged this model. So you can go on back and forth, but both the systems are talking to each other. So you have all the information flowing automatically. Next, let's talk about the other features. So once you move from experimentation to staging, you need to worry about features like sharing and collaboration. So you need to make sure that the teams and your stakeholders can easily, access your the registered model, as well as, edit and update on it. So that's the reason you need to have a system where you kind of have the full control on the type of access that you need to give to your users. So in this case, like you can go and decide the different permission levels. By default, for example, everyone in the org would have read-write access, or you may have very custom access level where you can say that everyone has a read-only access, and I will invite a specific user, in this case Jane Alice, and give her read-write permission. So I'll have a specific groups or teams who have more elevated privilege. So that's all about sharing and collaboration. And then again, that links back to security and access control, because you are kind of managing who can do what with your registry. And finally, ability to configure governance and approval workflows. And we have discussed that already, that you need to have more controls in place of who can approve your model, and then you can move the model through the life cycle. So I'll show you how that can be done. For example, let's say in this model V2, we can move this model from development to, let's say I request to move this to staging, please approve, and I can request approval. So immediately you know that a state change request has been made, and I would see that yes, it's in pending approval and someone needs to approve this, and anyone who has approved authority can go ahead and do that. And as well as there is an activity log that tracks all the activities that has been taken. So you kind of are auditing the process throughout. Now I'm just mimicking another user and going ahead and seeing what's the view of another user who has approval permission. What do they see? So in this case, I'm Jane, and I go here to this version, and I can see that, hey, there is a request to change from this model from development to staging. I can go ahead and review all the artifacts and decide that, yeah, it looks like it's good. It's good. Approved. Right? I confirm. And all my activities are logged here. And if you go back to the view of the user who has requested, now as you can see, this model has been promoted to staging. And at the end, I can gradually promote from staging to production and so on. And another thing, if you go back to the presentation here, is about automation. So in addition to moving and promoting the models through lifecycle stage and the approval workflows, another important consideration with model registries to ensure that it helps with automation and you're not really adding more ad hoc processes in the middle. So one thing that you need to worry about is having the right APIs or webhooks that can trigger downstream actions. So for example, if you have moved a model from development to staging, you should have the right controls in place that your deployment pipeline can pick that model, right? So they should be able to be in a stage where they're looking out for any stage change. So if something has moved from staging to production, let's say, the downstream application should track and automatically deploy the model. For example, I'll show you how a quick view. Like here, I'm just looking for the latest version model. Here, I'm looking for which is the latest model that has been registered, and it's model V2, and these are the attributes, and I have all the information. And I can go ahead and get the associated artifacts as well if I need to go ahead and deploy it. So again, for going back to the features, automation is really important, as well as the right configuration to promote the models. So for example, if you have, let's say, different clusters, you have a different dev environment, different staging and production, you want to make sure that when the models move from one stage to the other, the right clusters are picking up the model and deploying it. And also performance. So I just shared how you can fetch all the model artifacts. And if you have a 4 gig, 5 gig, or even bigger models, you need to make sure that the system that you're using is performant enough so that it really doesn't negatively impact your deployment pipeline. And finally, deployment, integration into your deployment systems. So you may have your own CI/CD pipeline, and you want to make sure that the registry talks well and integrates with your deployment system so that you don't end up creating another fragmented workflow. So this kind of concludes the demo that I wanted to share with you, and hopefully it gives you a picture of how you can integrate with your experiment management system, push your model to a registry, move it through different lifecycle stages, and manage all the information about the registry in one place. What are the benefits of model registry? First of all, model registry helps managing production-ready models. Second, it enables automation of your CI/CD pipeline, and it works well with your existing deployment infrastructure. Third, it enables more centralized governance of models, so all your models are in a single place and you're managing them well. Fourth, it enables clear handoff between data scientists and your ML infra engineers. And finally, it provides executive visibility into what models exist and their current status. Now, as the next step, I would recommend you to try this yourself. So we do offer a free trial at Verta. And what the features that you can try with the free trial is model versioning, experiment management, model registry that I just shared, as well as deployment and monitoring. So you can go to https://verta.ai/trial and sign up for the trial. The other option that you have is ModelDB 2.0, which is an open source version of our product. And that doesn't include model registry, but you can play with our system for model versioning and management. So you can go to GitHub and fork and play with the open source version as well. Thank you, and really appreciate your time today, and I'm open to questions now.
Great. Thank you so much. We have some great questions that have come from the audience. So Meeta, I'll go ahead and get you started. Our first one is, could you give one example of how model registry has helped with deployment automation?
Yeah, that's a great question. So I can give one example of one of our customers, how they have used registry in their deployment process. They have taken completely two different approaches based on their use case and how fast they want to move. So in one scenario, what they have implemented is a very stringent approval process, and then the releases in the backend is fully automated. So the user, like a data scientist, moves the model to staging. The next step, their data scientist peers, they kind of review, make sure that things are looking good and approve. Those changes are captured through, in the backend through API notifications, and automatically deployment is triggered in their staging cluster. And once the deployment is done, they trigger a batch test job, and again, this end-to-end process is fully automated. So the batch test job runs, and based on whether it's a success or a failure, let's assume it's a success, the model version label in registry is automatically updated that the test is successful, and tag it as ready to move to production. So that particular version is tagged as production ready. And again, from staging to production, that's they follow a very similar approach. So again, as you can see, there is a human oversight here because of the complexity of the model and how critical is it for the workflow. They want the data scientists to be in the loop and review and approve, but the entire backend is automatically, the rest of the things are taken care through automation. And the other approach that they have taken for some of their batch use cases is they do not want any human oversight. They want to make sure that things are visible to data scientists, but the batch job just automatically registers a model. It triggers testing. Once the testing is successful, the model moves from staging to production and subsequent clusters. So again, everything is fully automated in that scenario. But then all the activity log and everything is maintained so that a data scientist, they can go and review everything and what's happening, but nothing is blocked on any manual approval process. So again, depending on the use case and what type of approval and workflows that you want to introduce, you can have different deployment options, and you can automate it accordingly. And one thing that these guys have achieved is, I think they are deploying, releasing almost daily. So this type of automation really helped them a lot, to achieve this level of efficiency. I hope that answers the question. I can go to the next question and I'll try answering it. I think we have a question around what is the definition of a model in a registry? Do you include a model binary or the inference code or everything? That's a good question. So as I mentioned in one of the slides, that for us, we feel like model is just not the model code. To really, we have to ensure that the model, when you are putting it in an experiment phase or in registry, it includes so many different artifacts. So one is, of course, the model code, but then there is data, there is all the environment variables, and also the configuration. So all these things together really make sure that ensure that the model is reproducible and you have all the components in place. So for us in model registry, when you're registering a model, it's just not the code. It comes with all the model artifacts and data and everything. So when it comes to someone reviewing the model, someone downloading it, they have everything handy. So that's the philosophy that we have followed with the registry. And hope I answered the question, and happy to follow up later as well. I move to the next question. We have models running in different places, and we have a complex CI/CD process. How should we approach model registry? I think I covered what the different must-have features and things that's really critical for a registry. But this is a very relevant question, that if you have a very complex CI/CD process and you have a much more mature release cycle, how would model registry really fit in? And for us, I think I kind of see three key areas that you should look for. One is around how agnostic the model registry is, right? So what you've seen is in a typical data science world, you'll have both batch and real-time deployment. You may have deployment and serving infrastructure all across the board. You don't want to, the data scientists don't want to be restricted to one platform, right? So at Verta, we offer a deployment option as a module, but then we have seen customers using Verta. You may have Spark, SageMaker, Azure. You may be running your inference in multiple places. Again, that's another factor that should be considered in registry, as well as you may have a bunch of old models that you cannot just ignore them. That may not be running in one of the platforms somewhere. It may be some old legacy platform, and then you may have different environments or test staging. So there are so many parameters involved here. So I feel like when you're using a registry or building your registry, regardless of where the model is running and what the model is doing, which stage the model is, everything should be captured in the registry. The registry implementation should be very much agnostic to all these parameters. So I think that is one critical factor when it comes to a very complex infrastructure that when you are dealing with. The other factor that would be important here is how easy it is to integrate, right? You have your own CI/CD process, and we don't want you to rip and replace it. And then you are also be looking for a fair bit of automation. And this can only happen if you're using a registry that has very open and flexible APIs and event notification systems. So you can just easily tap into the registry and integrate it versus creating a lot of custom work, right, for yourself. And the third factor that is really important here that you should consider is performance. And I briefly touched upon that in the presentation as well, because one aspect is here is the number of models that we are releasing and also the size of the model. And in some cases, what we have seen is the size of the model is fairly big. And since registry is kind of a data warehouse for you where you're storing and retrieving all the models, it should be like it should be done quickly and without any significant overhead on your system. I'm highlighting this more because that's one pain point that I heard consistently about some of the other registry options that are out there. So something for you to consider. Again, agnostic, easy integration and performance. As long as you are hitting those 3 bullets, if you have a complex CI/CD process, a registry can really help and help you move faster and integrate much quickly. Hope that helps answer the question. Let me see. I think I have. I see one more question, so I'll quickly jump to that. We have a lot of focus on compliance and auditability. Not sure if and how model registry helps. I'll split this into 2 parts. One is about the we covered about the approval workflow and auditability of the model release process, and definitely registry provides that option. It also makes sure that you are not releasing a model without a thorough review process across the board. So that's a process aspect. But the second part is how to build a much more compliant registry feature that works in your, as per your company's, architecture and technical implementation needs. And I would say here the key things that you should look after is, of course, access control. That not everyone has equal access, so maybe some folks would have read access, some would have read write. You have to control who can approve, who can release. So having that granular access control really helps in your, at the end of the day for your compliance. And something that can integrate with your company's identity management system, and it's fairly easy to implement. That's also important here. The other aspect is we saw in the demo, the activity log. So that really is also important from a compliance aspect because you are kind of logging everything, where the model is, who is approving the model, when is it releasing, what timestamp. So you're kind of capturing all that in the activity log. That also at the end helps with your compliance. And the third aspect is the activity log is great, but it's kind of it's a part of your audit process. But what's also important is having a very detailed trail of actions with the right audit log. And you need to maintain that there so that you can go back and look at a timestamp and see who has deployed the model at what time, what happened to the model, and what actions have been taken. So again, with right access control, logging everything, and a very detailed audit trail is another approach to make sure that the registry feature is compliant and it is helping with your compliance needs. I hope that helps with the question, and let me know if you have any follow-up, questions around this. So I don't see any more questions, so I think we are good for now. You have my email address. You have more details about Verta's trial options, so please feel free to reach out to us. I will hand it over to Stephanie next to wrap this up. And thank you.